Alright, so atomic structure practice questions. First question here. Find the frequency of light having a wavelength of 456 nanometers. The frequency of light having a wavelength of 456 nanometers. What equation do you think we are going to use to be able to calculate the frequency of light having this wavelength? Anything that you know? Are you able to follow? Any equation that you know we can use?
I'm trying to remember the equations.
How long will it take for you to remember? So speed of light is wavelength times frequency. Speed of light is 8.0 times 10. Is it 8? 3.0 times 10 to the power 8. That is equal to wavelength 456. Nano means to the power negative 9. So convert it to meters. So I've converted to meters and then multiply by frequency. So simply divide both sides by this value. So over 456 by 10 to the power negative 9 over 456 by 10 to the power negative 9. So frequency is going to remain. I'll just say 3 divided by 456. That is given me 0.0065789. And then I'll say times. So now 10 to the power 8 divided by 10 to the power negative 9. Same basis dividing, subtract the power. So that will be 8 minus negative 9. That is going to be positive 17. Now the 0.00657, I can as well write it as 6.57 times 10 to the power negative 1, 2, 3 to the power negative 3. So therefore this can also be written as 6.58 times 10. So this is 10 to the power negative 3 plus. So same basis again, multiplying, you add the power 17 plus negative 3. That is going to give us, is it a 14? His. So that is going to be it. Is this okay?
Yes.
Okay. Calculate the wavelength of an electron traveling at 5% the speed of light. What equation do you think we're going to use for this one? Calculate the wavelength of an electron traveling at 5% the speed of light. So wavelength is, from the data we have, what we have is 5% the speed of light. So I can have Planck's constant over mass times velocity. So we are going to use the de Broglie's equation. Okay. Planck's constant is 6.626 times 10 to the power negative 34. Divide that by mass. This is an electron. The mass of an electron is a constant, 9.11 times 10 to the power negative 31. Then multiply by the velocity. This is 5% the speed of light. 5% is 5 out of 100. The speed of light. The speed of light is 3 times 10 to the power 8. So this is what we get to do. So what are we going to get from here? Let me start with the denominator, which is 9.11 times 10 to the power negative 31. And so we get multiply by 5% or 5 out of 100. 5 out of 100 is 0.05 times 3 times 10 to the power 8. So that will give us our 13.665 times 10 power negative 24. The answer that we get now is 6.626 multiplied by 10 to the power negative 34. So the answer we get now divided by the answer that we found from the previous working. Okay, so let just a moment, I punch this properly so I won't make a mistake. Alright, 6.626 times 10 to the negative 34 divided by the answer that we've gotten from calculation there. This is giving me 48.49 times 10 to the power negative 12. This is wavelength. What will be the unit?
Unit is going to be in meters.
It's in meters. Now 10 to the power negative 12, what prefix do you know which means 10 to the power negative 12? Okay, that's a pico. So basically this is 48.49 pico meter instead of writing 10 to the power negative 12. So this is it for this one. Then the next one, what do you think is, what equation are we going to use? Calculate the wavelength of the Bauma line with an electronic transition corresponding to N2 is equal to 3. What do you think will be the equation?
We're going to use that one that says energy is equal to negative 2.178 times 10 to the power forgotten, then
Mm-hmm.
multiplied by 1 over n final squared minus 1 over n initial squared.
Now that one is going to give you energy, right? So let's use the one for wavelength. 1 over wavelength is equal to, is it 1.097 times 10 to the power 7, then 1 over n final squared minus 1 over n initial squared, since we want to find the wavelength. So this is going to be 1 over wavelength being equal to 1.097 times 10 to the power 7, 1 over. Now for the Bauma series, which one is going to be the final energy? What does Bauma mean? Bauma line. From which?
Bauma line
Mhm.
is n is equal to 2.
N is equal to 2. So between these two, which one is going to be the final energy level?
The final energy level is n is equal to 3.
Okay, so every time you hear of Bauma, it means it's coming from somewhere to n is equal to 2. We don't care where it is coming from. So the final energy level is 2. Okay, so Bauma final is 2. If you hear of Lyman, final is 1. So it should be 1 over wavelength is equal to these words always tell us the final. So 1 over 4, this is minus 1 over 9. And then the answer we get times 1.097 times 10 to the power 7. This is going to give us, from what I can get, this is 152.3611. So if I want, this is the same as over 1. So if I want to make wavelength sub the formula, I'm going to take this on top, the one comes down. So meaning that even this will swap, one goes on top, this one comes down. Okay, so all we do is 1 divided by answer. And that is giving us 0.0065. Now I'm also wondering if I have used the right value here. Do you have the value for the Rydberg constant here we use?
No, what's that?
Okay, it's one. It's actually correct. I was just getting it from my mind. Let me just repunch what I've punched on the calculator. 1 over 4 minus 1 over 9. Okay, that is 0 point. So it is this one which is wrong. 1 over 4, oh sorry, I have not even completed. And then times 1.097 times 10 to the power 7. So I got a wrong value when I punched. So I punched wrong. Just make sure that you punch correctly because we end up losing marks for something that you know. 1523611.111. So all I'm going to do is take the inverse of now this value. So I'll say 1 divided by answer. That is 656. Okay. Times 10. Let me see how many decimal points are here. 1, 2, 3, 4, 5, 6, 7. So 6.56 times 10 power negative 7 meters. So if I move the decimal point 1, 2, this is going to be 656 times 10 to the power negative 9 meters. 10 to the power negative 9 is equal to what? What would be the prefix there?
A nano.
A nano. So this is 656 nanometer. So that is it. Okay, let's answer question. To this one, you can just tell me what is meant and who came up with the dual nature of light. What is meant and who came up with the dual nature of light? You know the answer? Yes? Can you read this?
Oh, Louis de Broglie.
So this is the one who came up with the dual nature of light. Dual nature of light says that light is both a wave and a particle. So that is it. Okay. Define photoelectric effect and state one condition that must be fulfilled for the photoelectric effect to be observed. What do you think is the answer for this one? What is the photoelectric effect?
This is when light is projected on a metal and electrons are emitted.
Okay, so now to state it as someone who is educated, you say the photoelectric effect is a phenomenon which states that when light is projected on a metal surface, electrons are going to be emitted from the surface of the metal. It is from the surface of the metal. So a condition, what would be the condition for the photoelectric effect to happen?
Not sure, but I think the threshold charge and energy something to do with that.
So the frequency of the energy which is striking the metal should meet a minimum which we call the threshold frequency or greater for the photoelectric effect to happen. So that is it. Correct. Okay, the threshold frequency of a metal is 6.0 times 10 power to the power 13 per second. Remember, frequency is given in per second, which is hertz. Calculate the kinetic energy of an electron when the radiation of frequency 1.0 times 10 power 14 per second hits the metal. So remember, we said kinetic energy is given by Planck's constant. Then you say frequency minus threshold frequency. So this will give us kinetic energy being equal to Planck's constant 6.626 times 10 to the power negative 34 And then frequency, the frequency of radiation is 1 times 10 to the power 14. Okay. We remove the frequency, the threshold frequency of the metal, that is 6 times 10 to the power 13. So what will be now the kinetic energy? Let's see what we get. 1.0 times 10 to the power 14 minus 6.0 times 10 to the power 13. So this is giving me a very big value, and then the answer that we get to multiply by 6.626 times 10 to the power negative 34. So this has given me 2.6504 times 10 to the power negative 20. What will be the unit?
Joules.
Joules. So if we ask to calculate the velocity at which electrons are going to be emitted, you know that kinetic energy is given by half mv squared. So you already know the kinetic energy, 2.65 times 10 to the power negative 20. So be equal to half. Mass of electron is 9.11 times 10 to the power negative 31. Then v squared, simply find v. You would have calculated your answer for this question. Okay, let's go to this one. The lowest frequency of light that will produce the photoelectric effect is called the threshold frequency. This frequency for iridium is 9.6 times 10 to the power 14 Hz. Will iridium display the photoelectric effect when irradiated with 50 nanometer ultraviolet light? Explain. I like this question. What do you think we are going to do for this one? It's a very simple question. What do you think we're going to do? I want you to think a bit.
I,
Mm-hmm.
yeah, let me think first.
Mm-hmm. So all you do is see what does this wavelength, what frequency does it correspond to? If it is greater than this frequency you are saying, the threshold, then the photoelectric effect is going to happen. If it is less, then it will not happen. You get that?
Yes.
So speed of light is wavelength times the frequency. This is the 3 times 10 to the power 8. That is going to be equal to wavelength is 50 nanometers, which is 50 times 10 to the power negative 9 times frequency. So frequency is going to be 3 times 10 to the power 8 divided by 50 times 10 to the power negative 9. So all we do is 3 divided by 50. That will be 0.06. Then times 8 minus negative 9, it is going to be 17 Hz. This one I can also write it as 6 times 10. This is 1, 2. So to the power 15 Hz. So which one, what do you think? This is the frequency that we've projected. Is the photoelectric effect going to happen?
No. Yes.
Yes, it's going to happen because the velocity, I mean the frequency of radiation striking uh, the surface of the metal is greater than the threshold frequency. So I'll allow you to answer this one because it's basically the same. An electron in the hydrogen. Okay, let's answer this one. It looks interesting. An electron in the hydrogen atom in 1s ground electron state has an energy of negative 2 times 10 negative 2.18 times 10 power negative 18 joules. Calculate the ionization energy of hydrogen atom in joule per mole. So basically what we have, these questions, I remember meeting them in my test 1. Okay, you have got an hydrogen like that. So 1s ground electron. So I've got an electron in the 1s here. It has got this energy, negative 2.18 times 10 power negative 18 joules. So I want to calculate the energy of full hydrogen in joules per mole of ionization. Now ionization is the loss of hydrogen from this 1s orbital to n is equal to infinity. So when an electron moves from any energy level to the infinite energy level, the energy required for that to happen is uh, what we call as ionization energy. So energy is actually given by negative 2.18 times 10 to the power negative 18. So in the first energy level, this is the Planck's constant is the energy that the Rydberg constant is the energy that an electron possesses in the first energy level. So this is going to be negative 2.18 times 10 to the power negative 18. That will be 1 over final energy level. What will be the final energy level?
Infinity.
Infinity squared minus 1 over the initial is 1 squared. So give us negative 2.18 times 10 to the power negative 18. 1 over infinity. Infinity squared is infinite. Like a very big number, if you square it, it will still be a very big number. So infinity squared is infinite. 1 over a very big number is 0. 1 over infinity is 0. And then you have got negative 1 over 1, which is negative 1. So if you get a multiplier, you're going to have 2.18 times 10 to the power negative 18 joules. So this is the ionization energy. Now this is in joules. You want the answer in joule per mole. Joule per mole. Watch out. This came like such questions came in test 1 for last year. Hope it will be similar anyway. So now this energy that you are seeing is the energy of an electron. Okay, of an electron, or joule per electron. An electron is a particle. So that is the energy per particle. So if I want to convert from to energy per mole, so I'm going to say energy is equal to, this is positive 2.18 times 10 to the power negative 18 joule per particle multiplied by, I've got a particle down, I'll put a particle on top, and then a mole down. We know that in one mole we have got how many particles?
6.022 times 10 to the power
Times 10 to the power
23.
Okay, so it is 6.022 times 10 to the power 23. Avogadro's number. So times 6.022 times 10 to the power 23. That is going to give us energy being equal to 1312796 joule per mole. At times I'll tell you kilojoule per mole. So to convert to kilojoule per mole, simply again multiply. I've got a joule here. We're going to put a joule down and then a kilojoule on top. In 1 kilojoule, I've got 1,000 joules. So just divide this value by 1,000. 1, 2, 3. So it would be 1312.796 kilojoule per mole. As simple as that. That's okay.
Yes.
Okay. What is the de Broglie wavelength of a helium atom of atomic mass 4.03 atomic mass units traveling at a speed of 1000 meter per second? One atomic mass unit is 1.6605 times 10 power negative 27 kg. So, how do you find the Broglie wavelength?
Maybe we use the wavelength is equal to Planck's constant over mass times the velocity.
Very good. That's the equation for de Broglie. This is the one you use. Okay. So, Planck's constant 6.626 times 10 to the power negative 34 divided by mass. You are just going to get is 4.003. You multiply by 1.6605 times 10 to the power negative 27, and then multiply by velocity is traveling at 1000. So let's see what we get. 4.003 times 1.6605 times 10, then to the power negative 27 multiplied by 1000. The answer you get, you now say 6.626 times 10 to the power negative 34, then divided by answer. So this is giving me 99.68 times 10 to the power negative 12 meters, which we can also say 99.68 picometers. What is the wavelength of the yellow emission, sodium emission, which has a frequency of 5.09? So we've been answering this a long time. Here we've been given the frequency. So speed of light, wavelength times frequency. C is 3 times 10 to the power 8, and that to be equal to wavelengths. Frequency 5.09 times 10 to the power 14. So just find the wavelength that is going to be